So we're continuing our work with limit definition of derivatives. We're really just doing more of the same thing. I'm just going to show you how you can apply it to different other types of functions. We just didn't have enough time to do them all last time. So let's go ahead and begin here. Just as a quick review, last time we were using the limit definition of a derivative. The limit definition of a derivative, you don't need to write this, is the following. Where this represents y2 minus y1, this represents x2 minus x1, it's the slope. But it's the slope as the y2 and the y1 slowly become the same point. So the delta x represents a little bit more, is what it means, right? Change in x is what it means. But like, so you have x plus a little bit more, minus just f of x, right? And then we want to find out what is the slope becoming as that little bit more becomes less and less and less until finally it's 0. And so you end up with an instantaneous slope at one point instead of an average slope across 2 points. Now today, I'm going to show you guys what you'll probably see a little bit more often. But you do see this delta x is that you can use any letter here, but common one they use is h. You don't need to write this because we're going to do it all day anyway, but it's not uncommon for people to think, okay, that delta x is really ugly. It gets mixed up with the x all the time. So let's just use a different letter completely, and a lot of times they use h. So I'm going to be doing that today. So let's go ahead and begin. The first thing that we want to do is want to find our y2, right? So we want to find f of x plus, I'm going to call it h now, right? We're going to get away from delta x today, just because we can. And it's 3 over 2 times, what goes in the parentheses? X plus h. And then we're going to simplify that, right? So it's going to be 3 over 2x plus 2h plus 1. And then we go ahead and we go into our limit definition of a derivative. And we're going to have y2 minus y1, which was the original function, all over x2 minus x1, which we're just going to call h. And this is a complex fraction, so really we're just kind of reviewing some of our limit stuff that we learned earlier this year. So what we learned earlier this year was to remove the discontinuity when you're working with complex fractions is you multiply everything by the little denominators, right? So I'm going to multiply everything by 2x plus 1 first here. And when you do this, I would recommend you guys use parentheses, because a lot of times you're going to end up having to distribute somewhere, and if you don't put the parentheses, you're probably going to miss that. So that cancels that. So I'm not really showing you guys any new calculus topics today, just old calculus topics and algebra stuff for more complicated looking problems, but other than that, pretty much the same stuff. But I found that if I don't explicitly go over types of problems like this, they stump people. So I figured we'll talk about them today. All right, now I want to get rid of that other denominator, right? So now I multiply everything by 2x plus 2h plus 1. And then these cancel, right? That was the whole purpose of it. Okay, so now on the top I'm left with 3 and then 2x plus 1 minus 3 and this all over this. And then from there, the problem should be pretty much like what we did last time. Just combine your like terms and stuff. So to begin with, we're going to start by distributing. Now, mind you, we're distributing a -3 here, so everything's going to change its signs. Anything without an h on the top usually cancels out. And I'm left with a -6h on the top there. And the h's go away. And that's removing the discontinuity. Am I going too fast? I feel like I'm going fast. So now I've got that. And this. And then we're going to do our direct substitution. So I'm going to plug 0 in for this h over here. And since I did my direct substitution, notice the limit goes away at this point. And what's another way to write the bottom? There you go. All right, so there's that. So, I mean, you guys don't need to write this part. I just want to show it to you, though. Our original function was this, right? Right? Okay, so we learned how to do these a little while ago. There's 2 ways you could do it. I'm going to do it this way. Here's our shortcut if you want to review your shortcuts. You can move that to the top of the -1, right? Then you could do the power rule and the chain rule. So the derivative of the outside is going to make that become a -3. Don't change the inside. Take 1 away from that. And then multiply it by the derivative of the inside. Now -3 times 2 is -6, and then the 2x plus 1 drops to the bottom squared. So there's our nice little shortcut that we learned, right? That one's not quite as short as our regular shortcuts, but it's still shorter than the limit definition, but it still works. All right, so I'm going to throw one of these at you guys. Let's say g of x is equal to, you guys want me to be mean? Little mean? Completely kind?
Yes.
Booty, come on. All right. Let's do x minus 1. All right, go for it. I'll be nice. I know. Here's the if you want a challenging one. It's not that much worse. Just a little bit. Just a little bit. Let's do example 2 here. Let's say f of x is equal to the square root of x minus 3. I'll put a 2 in the front. Why not?
2 square root?
Yeah. A little bit. All right. There we go. Huh?
It looked like an X because the pen was
Oh.
on it.
So, y2 will look like this, right? Just has an x plus h in there instead of just an x. y1 looks like this. And there we go. You guys remember how to fix that situation? Rationalize it. Multiply the top and the bottom by the conjugate, right? So, here we go. We have 2x plus h minus 3. And it's going to be a plus here in the middle now, right? Change the sign in the middle between the two radicals. And whatever you do to the bottom, you do to the top, and vice versa. Okay. So when we do the bottom is pretty easy. You're just going to put it down there exactly as it's already written. In parentheses there. On the top, however, we're going to do this one times this one. So 2 times 2 is 4, right? And what's the square root of h minus 3 times the square root of h minus 3? X plus h minus 3, sorry. So it basically just cancels out the root, right? We're in calculus, guys. They should probably pay attention. All right. And then we do here, right? 2 times 2 here is 4. And then this times this is x minus 3. And then the negative takes over there, right? Okay, we're going to go ahead and distribute. Distribute again. Cancel. So on the top, I've got 4h over h. And then we're good to remove the discontinuity, right? So we have 4 over this now. Direct sub. We don't write the limit now, right? And then here's kind of the weird little algebra step for you guys. These two expressions are identical, right? So we're just going to combine them. If I've got 2 square roots of x minus 3, and I'm adding to it 2 more square roots of x minus 3, then I have 4 square roots of x minus 3. You basically just add these two coefficients together. And then this is going to reduce. You're left with that. There's your derivative. I'll let you guys practice one for a sec here. Say g of x is equal to square root of x minus 1 there. Try that. I'm going to save you a little bit of time, okay? So you start with x to the 3rd power. And then it's going to be going down 1 each time. And then on the other side, you start at h to the 3rd power. You come up 1 each time. And these two in the middle have a coefficient of 3. So that can save you a little bit of time today, so you don't have to FOIL it out. It would still, you guys could do it old school style, but I'm just telling you the answer there in advance, so save you some time. Okay? Other than that, I think that's all I'm going to torture you with for the day. Okay?